Let's go to this second part of the question. The second part of the question states, prove that QPTS is a cyclic quad. QPTS is a cyclic quad. Let me repeat my words again. Earlier on I said there are three ways of proving a quad to be cyclic. If the exterior angle of a quadrilateral is equal to the interior opposite angle, then the quad will be cyclic. If you look at this one, if Q3 can be equal to angle T, if Q3 can be equal to the whole of angle T, then it means QPTS will be a cyclic quad. Secondly, if the opposite angles of a quadrilateral are supplementary, then the quad can be cyclic. Look, angle T plus Q1 and Q2. Those are the opposite angles. If they give you 180, you can conclude by saying a QPTR is a cyclic quad. Lastly, if the angles subtended by the same side are equal, check. If you can prove that angle P2 is equal to T2, but P2 and T2 don't have much information on them. Or alternatively, if you can prove that P1 is equal to Q2, check P1 and Q2. Can we prove that? At least we have talked about Q1. Alternatively, if you can prove that Q1 is equal to S1, now that one already, we have already worked it out. If Q1 can be equal to S1, because Q1 is subtended by PT, S1 is also subtended by side PT. If angles subtended by the same side of a quadrilateral are equal, then that quadrilateral is then cyclic. So in this case, see, if you can prove that angle Q1 is equal to angle S1, because Q1 and S1 are subtended by PT. And already if we weigh options, now you can see already we can work that one out. Now let's work it. Remember, the information that is indicated here is when we are just analyzing the problem. Let's go to 5.2. 5.2. We want to prove that Q1 to be equals to S1. That is our destination. Ask yourself a question. When will QPTS be a cyclic quad? When will QPTS be a cyclic quad? The answer is if S1 can be equals to Q1. Now we're going to work it out properly to prove that S1 is equals to Q1. Remember, already I said P1 is equals to S1. It's very much important to provide appropriate reasons. This is a Euclidean geometry. In Euclidean geometry, you need to provide a statement, a reason for your statement. Why do we say P1 is equals to S1? Because TS is equals to TP. Why do I say TS is equals to TP? Because those are the tangents. Tangents drawn from the same point. In full, the theorem states tangents drawn from the same point outside the circle are equal in length. That's why we say T is the common point. That's why we say TP is equals to TS. So we've got P1 is equals to S1. But remember, P1 is equals to Q1. Remember that. P1 is equals to Q1. Why? Because check the given information. It was given. Q1 is equals to P1 from the given statement. Therefore, this is given. From the two statements, P1 is equals to S1, P1 is equals to Q1, we draw a conclusion. Therefore, it means S1 will then be equals to Q1. They are both equals to S1. Both equals to angle S1. Both equals to angle S1. Now, if S1 is equals to Q1, remember that was the destination target. This was our target. This was our destination. This is where we want to come in order to prove that QPT is a cyclic quad. That's where you want to come. Therefore, we have arrived at that stage to say S1 is equals to Q1. Now you draw a conclusion. Therefore, QPTS is a cyclic quad. Why do we say QPT as isosceles quad? Because the angles, because PT, check side, PT subtends equal angles. Thank you. That's how we prove that QPT is isosceles quad. The last part. I think we have done that. Still have to prove. TQ, we need to prove that TQ bisects SQP. The last part. TQ bisects SQP. We need to prove that TQ bisects SQP. We need to simplify that one. What do we mean if we say TQ bisects SQP? Check TQ. Here is TQ. Here is angle SQP. This angle. If we want to simplify this one further, it means all we have to do is to prove that angle Q1 is equal to angle Q2. If we want to simplify that one, TQ. Here is TQ. SQP. Here's SQP, angle SQP. So if TQ bisects angle SQP, it means Q1 will then be equal to angle Q2. That is what we want to prove now. Let's start. We want to prove that angle Q1 is equal to angle Q2. Remember 5.2. What did you do in 5.2? In 5.2 here, we have proven that QPT is isosceles quad. We have proven that QPTS is a cyclic quad. Because we have proven that it's a cyclic quad, we can apply the theorems of a cyclic quad there. You remember the theorems associated with cyclic quad. Exterior angles also interior opposite angle. Opposite angles are supplementary, and angles supplementary the same chord or angles supplementary the same arc are equal. Now, let's apply. Let's prove. It's 5.3. 5.3. We start. We want to prove that Q1 is equal to Q2. Look for angles that are equal to Q1. P1 is equal to Q1. The given information. P1 is equal to Q1. This was given. This was given. Remember? Here. P1 is equal to Q1. This was given. Then look at P1 is equal to Q2. P1 is equal to angle Q2. Think of the reason. Why do we say P1 is equal to Q2? Why do we say angle P1 is equal to angle Q2? Let me give it, because those are the angles subtended by same chord. This chord in this case will then be TS. TS. And P1 is equal to Q2, angles subtended by the same chord. That chord will then be TS. Remember, in 5.2, we have proven that QPTS is a cyclic quad. So remember, the sides of a cyclic quad, they form chords of a circle. Sides of a cyclic quad are basically the chords of a circle. That's why I'm saying TS is then a chord. So TS subtends angle P1, and again TS subtends Q2. Therefore, P1 is equal to Q2. Those are the angles subtended by the same chord. Thank you. From the two statements, we draw a conclusion. Therefore, Q1 is equals to Q2. So if angle Q1 is equal to angle Q2, what does that mean? It therefore supports the statement that TQ bisects angle SQP, angle SQP. The word bisect means to cut into two equal parts. That's why we say Q1 is equal to Q2. I hope you are enjoying yourself at the moment. We are just busy with the application of the theorems. We are applying the theorems. Mathematics, in maths, we believe that practice makes perfect. So it's through practice that we become better and better in mathematics. So I'm going to give you another exercise again while I'm having a cup of water. Give you one exercise. Apply your theorems and see how far do you go.